Precalculus review of algebra prior to calculus part 5, rational and absolute value equations inequalities. In this video lesson, I'm building upon the work of Canadian math teacher Jeremy Clausen. I'm going to try to include a link to his channel below. I'm using his problems here, but with my own slant. Check him out, I recommend. Okay, first thing we're going to go to is rational inequalities. And in calculus, we look for something we call critical numbers. I'm going to explain briefly what they are. Critical numbers are numbers where an expression is equal to 0 or undefined. And so we're looking for the numbers where the numerator is equal to 0, in which case the value of the expression will be 0, and or the value of the denominator is 0, meaning where the expression is undefined. And so what we do is we can take our numerator and set it equal to 0, so we have 2x plus 1 is equal to 0. And we get a critical number there, and also we can set the denominator equal to 0, in this case x squared plus 1, and then solve for x. We have 2x is equal to negative 1, and so x is equal to negative 1/2. And so that is a critical number for us. And similarly, if we subtract 1 from both sides of this other equation, we have x squared is equal to negative 1, and taking the square root of both sides, we have x is equal to plus or minus the square root of negative 1. Well, the square root of negative 1 is the imaginary number I, meaning that is not a real solution. And so what that means is for this denominator of x squared plus 1, there is no critical number associated with that. And now we're going to put together our critical numbers in the numerator and denominator in this fashion. What we do is we fashion a set of number lines, and the number line above we use for analyzing the numerator, in this case 2x plus 1, and we look along that line for the critical number and mark this, mark negative 1/2 below, and above we put what the value is going to be, which is 0. And then for denominator, we can put the denominator down here, x squared plus 1. And basically we're concerned this 0 in the numerator breaks up our number line between less than negative 1/2, 0, and greater than negative 1/2. And if we take a number less than negative 1/2, we put the sign along the top of this number line. And so a number less than negative 1/2 will produce, if you examine, say we pick negative 1, well, 2 times negative 1 is negative 2 plus 1 is negative. So our region, our sign to the left in the numerator of negative 1/2 is negative, and to the right is positive. Now, for the denominator, there is no critical number associated with the denominator, so we have a plus here, a plus here, and a plus here. And now below this number line, we make a summary, kind of a summary of the signs, and we have to the region to the left of negative 1/2, we have a negative divided by a positive, which is negative. And then at x equals negative 1/2, we have 0 divided by a positive, which is 0. And to the right of negative 1/2, we have a positive divided by a positive, which is a positive. And so now we are prepared to make a summary statement because we've done all the analysis to conclude what we need to conclude. So we have this inequality, 2x plus 1 over x squared plus 1 is greater than 0. And so what we do is we look for the summary statement where we have a plus sign, meaning greater than 0, on the interval of negative 1/2. Now we have to look to see if we have greater than. So what that means for us is that negative 1/2 is not included as part of the solution set, and we go for that all the way to less than infinity. So that's what that looks like. And so that's really the system, and we're going to go over this for several problems. I encourage the viewer to work ahead as much as possible. And we go to problem B. Okay, to find our critical numbers, we set our numerator equal to 0, so we have x plus 2 is equal to 0, so x equals negative 2. And for our denominator, we have x minus 3 equals 0, so x equals 3 is our critical number. Now we can fashion our number line as our number lines, rather, as our analysis tool. And on the top one, I'm going to place x plus 2, and the bottom one, for representing the denominator, we put x minus 3. And we look where these critical numbers are, and so we'll put, you look at the numbers, we have negative 2 and 3. Well, we want to put them relatively in the right position, so I'm going to put negative 2 over here on the top number line and 3 over here on the bottom number line. And now analyzing this x plus 2 numerator, we have the value of 0 at x equals negative 2, and to the left of negative 2 we have a negative sign. And then I continue to put to the right we have positive, so I put positive here, a positive over this 3, and then to the right of 3 another positive. So we're going to have 5 intervals or points of analysis to consider. And now for this value of 3 in the denominator, with the number line represented by the denominator, we're going to have a 0 right here at 3, and to the left negative signs. And you can see that any number less than 3 is going to make the denominator negative. So negative here, negative here, negative here, and to the right of 3 we have a positive sign. So now we're prepared to make our summary for analysis. And so we just look at negative divided by a negative is positive. We have 0 divided by a negative, which is 0. We have a positive divided by a negative, which is negative. We have a positive divided by 0, which is undefined. And finally we have a positive divided by a positive, which is positive. And so now we're ready to make our statement. And so the inequality, x plus 2 over x minus 3 is greater than or equal to 0. And so we just look where we see that, and we have a positive sign which is greater than 0 on less than infinity, or greater than negative infinity, up to the x value of -2. Now we look and we see, well, is -2 included? Well, we have a 0 down here. I mean, we have a greater than or equal to symbol, so we can just go ahead and bracket this -2 in this manner. And then we have another positive region to the right, and that's going to start occurring at 3. Now, is 3 included? Well, we have undefined. The function is the expression is undefined where x equals 3, so 3 is not included. So we put a parenthesis here, and then comma, infinity. So that's going to be our problem worked out here. Okay. Let's go on to C. We have x squared plus x over quantity x minus 1 cubed. So again, we find our critical numbers. What I'm going to do is take this x squared plus x and rewrite this in factored form as x times quantity x plus 1, and set that equal to 0. And our denominator, we're going to have quantity x minus 1 cubed is equal to 0. Now, just solving, find our critical numbers. X is going to be equal to 0. X is going to be equal to -1, representing the critical numbers from the numerator. And then in the denominator, x plus 1 is equal to 0, so x is equal to 1. So those will be our critical numbers. Again, we construct our number lines. Let me do that. I want to leave a little more space here below. Okay, on the top I'm going to write x times quantity x plus 1. And for the denominator, I'm going to write quantity x minus 1 cubed. And then we look at our critical numbers and write them in order. So our -1 in the numerator comes first, followed by another 0 in the numerator, and finally by a 1 in the denominator. So let's go look at the numerator first. The value is 0 at each of these critical numbers in the numerator. And let's first consider a number less than -1. If we would have a negative times a negative. Between -1 and 0, we would have a negative times a positive, which would be negative. And then to the right of 0, we would have a positive times a positive. And then I'm going to write another positive sign over x equals 1 and also greater than 1. So we're going to have 1, 2, 3, 4, 5, 6, 7 intervals or x values represented. Now for our denominator, we know we have 0 where x equals 1, and to the left of 1, if we plug in 0, for instance, we would have -1 cubed, which would be a negative number. So we're going to have negative here. And notice we're lining up underneath all these regions here. And then to the right of 1, we have positive. And so this is going to be what we have here. Let's go ahead and make our summary. First of all, we have positive divided by a negative, which is negative. We have 0 divided by negative, which is 0. We have negative divided by negative, which is positive. We have 0 divided by negative, which is 0. We have positive divided by negative, which is negative. And we have positive divided by 0, which is undefined. And finally, we have positive divided by positive, which is positive. And now we can create our summary statement, which is going to be x squared plus x over quantity x minus 1 cubed is less than 0. And we just look at our summary line on, we're looking for the negatives here. Well, here we have a negative for greater than negative infinity up to negative 1. And is negative 1 included here? Well, we have less than, so negative 1 is not included. And where else do we have less than? Between x equals 0. And again, 0 is not included because of this less than. So 0, comma, up to 1, where we have we're undefined. So that's going to be it for C. Next, D. Here we have 5x over quantity x squared minus 1 squared is less than or equal to 0. So for our numerator, we have 5x is equal to 0, so x equals 0 is our critical number. Now for our denominator, we have quantity x minus 1 squared, so I'm just going to write these separately. X squared minus 1, x squared minus 1 equals 0. So I just separated those two. We had squared, so I expanded in a way. And now we have further expansion opportunities because we can rewrite this first x squared minus 1 as quantity x plus 1, quantity x minus 1. And the second one, same thing, x plus 1, x minus 1 is equal to 0. And now we can combine the like linear binomials as quantity x plus 1 squared times quantity x minus 1 squared equals 0. So we have critical numbers of x equals negative 1 and also of x is equal to 1. So now we can take our number line. I'm going to write over here to the left to give a little more room. So our number line for the numerator, I'm going to put 5x on top here. And for the denominator, I'm going to put, I'm going to write it like this. Quantity x plus 1 squared, quantity x minus 1 squared. And then we look at the critical numbers we have, negative 1, 0, and 1. So I'm going to put negative 1 down here because that's for the denominator. I'm going to put 0 up here for the numerator and positive 1 down here for the denominator. Now looking at the numerator, we have at x equals 0, the value of the denominator is 0, and to the left of 0, the denominator is negative. So I put a negative over this interval, a negative over this negative 1, and a negative sign left of negative 1. And to the right of 0, I put plus, and then a plus, and then to the right of 1, a plus. So again, we have 7 intervals or x values that we're going to have represented. Now we look at our denominator. Well, we definitely have the denominator equal to 0 at x equals negative 1 and at x equals 1. And because of this of squared, the squared turns everything positive, and we could look at the whole original denominator if we want to, and we would realize that we would have positive signs everywhere else. Okay, so now we're ready for our summary. And for our summary, we have negative divided by a positive, which is negative. We have negative divided by 0, which is undefined. We have negative divided by positive, which is negative. 0 divided by positive, which is 0. We have positive divided by positive, that's positive. Positive divided by 0, undefined. And positive divided by positive, which is positive. And now for our statement, we're going to have 5x, I'm just rewriting the original here, of quantity x squared minus 1 squared is less than or equal to 0 on the interval of, and we just look for less than or equal to, so we see a negative sign first thing off, so from greater than negative infinity up to negative 1 and undefined at negative 1, so negative 1, and that's going to be parentheses, and then to the right of negative 1, between negative 1 and 0, so we'll put negative 1 here, comma, and then all the way up to 0. Now, is 0 included? Yes, because of less than or equal to. So this is what that is going to look like. Okay, so that's going to be that one. Next, E. We have 2x minus 3 over x plus 4 is less than or equal to negative 1. Now here we don't have the right side equal to 0. So this is going to take a little bit of doing because we want to get our right side equal to 0. And so for that we're going to add 1 to both sides of this inequality and rewrite therefore as 2x minus 3 over x plus 4 plus 1 is less than or equal to 0 now. And our common denominator will be x plus 4. So in these things we want to get a common denominator. And let's do that. Okay, what we have to get our common denominator x plus 4, we have to multiply. I'm just going to rewrite this 2x minus 3 over x plus 4. We have to multiply our denominator by x plus 4 to get our common denominator, and likewise we have to do the same in the numerator. So we replace this 1 with x plus 4 over x plus 4. And now having that common denominator, we can take 2x plus x, so we'll get 3x, and then negative 3 plus 4, which is plus 1, over x plus 4. And all this is going to be less than or equal to 0. So it took a little bit of doing, but we were able to get a single rational expression. And let's go find our critical numbers here. For the numerator, now we have 3x plus 1 is equal to 0. So we have 3x is equal to negative 1, so x is equal to negative 1/3. And for our denominator, we have x plus 4 is equal to 0, so x is equal to negative 4. So those would be our critical numbers. And now we can create our number lines for analysis. And first we have, for our numerator, 3x plus 1, and for our denominator, x plus 4. And just looking at these values here, the first one we see is negative 4, which is represented by the denominator. So I put this over here on the denominator line. And then in the numerator, we have negative 1/3. So it's just getting these things in order. And now at negative 1/3, the numerator value is 0. And to the left of negative 1/3, we have that numerator value is negative. So I put a negative sign here in this interval, a negative sign over the negative 4, and also another one to the left of negative 4. And to the right of negative 1/3, we are going to have the numerator as positive. Now for our denominator of x plus 4, we have that denominator 0 at x equals negative 4, and negative to the left of negative 4. And then we have a negative sign, a positive sign here, positive sign here, and positive sign here. So we have 5 x values or intervals to consider. And now for a summary, let me just give a little more room here on this. We have negative divided by negative, which is positive. We have negative divided by 0, which is undefined. We have negative divided by positive, which is negative. We have at negative 1/3, 0 divided by positive, which is 0. And finally, to the right of negative 1/3, we have positive divided by positive, which is positive. So we are interested in less than. So we will conclude that 2x minus 3 over x plus 4 is less than or equal to negative 1 on the interval of, and we look for the negative here, and we first see negative starting at greater than negative 4, and that all the way up to negative 1/3. And is negative 1/3 included? Yes, because of less than or equal to. So this is what we have here. Okay. Next. Now we have this rational inequality. We have 3 over x plus 2 is greater than or equal to 2 over x minus 1. And so we want to make this right side equal to 0, so we can rewrite this inequality as 3 over x plus 2, and subtracting the right side we'll have minus 2 over x minus 1. And now we have a greater than or equal to 0. And we can get a common denominator, and our common denominator we can get by multiplying our denominators together. So that's going to be quantity x plus 2 times quantity x minus 1. So now let's go ahead and apply So we have 3 times x plus 2, and what do we multiply this by to get our common denominator? We're going to multiply by x minus 1 over x minus 1, and minus 2 over x minus 1, and what do we multiply this by? Well, it's going to be x plus 2 over quantity x plus 2. And all this is going to be greater than or equal to 0. So now we're going to try to put it all together. So we have 3x minus 3, and then we have, for this other one, minus 2x minus, because that minus applies, minus 4, and all this over quantity x plus 2 times quantity x minus 2, and all this again is greater than or equal to 0. And finally we have 3x minus 2x, which is x, and negative 3 minus 4, which is minus 7, over quantity x plus 2 times quantity x minus 1. And I've made a little transcription error here. Let me fix that. It's going to be minus 1 right there. Okay. And all this is greater than or equal to 0. And so now what we can do is we can make our number line, and I'll do this up here. And for our numerator, we have x equals 7. That's one critical number. And for denominator, we have x is equal to negative 2, and also x is equal to 1. So for our numerator, we have x minus 7, and for denominator we have quantity x plus 2 times quantity x minus 1. And now we just try to put these in order here. Our critical numbers are going to be negative 2, 1, and 7. So I'm going to put negative 2 and 1 here in the denominator, and 7 up here in the numerator. And for the numerator first, at 7, the value is 0, and to the left of 7, we have negative, so negative sign here. Above the 1, we have a negative. Between negative 2 and 1, we have negative. At x equals negative 2, we have a negative, and to the left of negative 2, we have negative also. And to the right of 7, we have positive. So again, 1, 2, 3, 4, 5, 6, 7 intervals or x values represented. Now for our denominator, left of negative 2, we're going to have a negative times a negative, or a positive. At negative 2, we'll have 0. Between negative 2 and 1, we'll have a negative times a positive. Then at 1, we will have 0. And greater than 1, we'll have a positive times a positive. So again, we have everything represented. And now for our summary, we're going to have negative divided by positive, which is negative. Negative divided by 0, which is undefined. Negative divided by negative, which is positive. Negative divided by 0, which is undefined. Negative divided by positive, which is negative. 0 divided by positive, which is 0. And positive divided by positive, which is positive. So now we can make our summary statement, which is, in this case, 3 over x plus 2 is greater than or equal to 2 over x minus 1 on the interval of, we're looking for greater than, so we're looking for plus greater than or equal to. So it looks like at negative 2 is where we start seeing that plus in our summary statement. So I'm going to put parentheses negative 2, comma, up to 1, and is 1 included? No, it's not, because of undefined, right? And then we don't see a plus sign over here until after the 0. So at 0 is 0 included? Well, we have greater than or equal to, so yes, 0 should be included. And then comma, infinity. And so this should be it for F. Except that's going to be at 7, so it's not 0. I'm getting kind of confused, right? Because of that 0 there, it should be 7. Let me fix that. There we go. Yeah, it's easy to make transcription errors in this, so that should be good now. Okay. Now we have 2 over x is less than or equal to 1 over x minus 1. And so the first thing we'll do is set our right side equal to 0 and just rewrite this as 2 over x minus 1 over x minus 1. And that is going to be less than or equal to 0. And so our common denominator for these fractions is going to be x times quantity x minus 1. And now rewriting each of these fractions, first we have 2 over x, and we have to multiply by x minus 1 over x minus 1, and then minus 1 over x minus 1. And what do we have to multiply this by? Well, x over x. And so that's going to be all less than or equal to 0. And so now we have everything we need. We have 2x minus 2 right here distributing, and we have minus x over x times quantity x minus 1. And so we have 2x minus x, which is x minus 2 over x times quantity x minus 1. And that's all going to be less than or equal to 0. And so for our critical numbers, we have x minus 2 is equal to 0, and x times quantity x minus 1 is equal to 0. So x is equal to 2 is one of our critical numbers. Then we have x is equal to 0, and also x is equal to 1. So we have 0, 1, and 2 as our critical numbers. And we can draw our number lines for analysis here. And we're going to put our numerator up here, x minus 2, and our denominator is going to be x times quantity x minus 1. And then our numbers are 0, 1, and 2, and the 0 and 1 are in the denominator, so I'm going to put 0, 1, and 2 up here for the numerator. And for the numerator, at x equals 2, we have 0. And to the left of 2, we have negative. So do you see how I'm lining these negative signs up over the x values and intervals? So everything is accounted for. And to the right of 2, the numerator is positive. And now for our denominator, we have x times quantity x minus 1. Well, to the left of 0 we have negative times the negative. At 0 we have 0. Between 0 and 1 we have a negative times a positive. At x equals 1 we have 0. And to the right of 1 everything is positive. So positive sign here, positive here, positive here. Now we're ready for our summary. And for our summary, we first have negative divided by positive, which is negative. Negative divided by 0, which is undefined. Negative divided by negative, which is positive. Negative divided by 0, that's undefined. Negative divided by positive, negative. 0 divided by positive, which is 0. And finally, positive divided by positive, which is positive. And so now we have everything. We're looking for, we can just write our statement here, which is 2 over x is less than or equal to 1 over x minus 1 on this interval of, we're looking for less than, so we look for the negative signs in our summary statement. So we go from negative infinity up to 0. And is 0 included? No, because at 0 we're undefined. And then the next negative we see is between x equals 1 and 2. So u 1 comma 2. Now at 2, is 2 defined? At x equals 2, yeah, we have less than or equal to. So we're okay at 2. Okay, that looks good. Okay, so that's going to represent all the rational inequalities that we're looking at. We're going to go next to absolute value equations. For A, we have the absolute value of x equals 4. And what we have here is, this is a true statement if x is equal to 4. And what else would happen? Well, could x also be negative 4? Yes, it could be. So the way to do this is take this x and put the negative sign over here. So x can be positive 4 or negative 4. And we can write this in different ways. We could write this as x is equal to plus or minus 4. We could write this alternatively as x is equal to, in set notation, negative 4 comma 4. In interval notation, we could write this as negative 4 union 4. I'm not going to write all the methods in the future, but those are possible things you can see. Next, for B, we have absolute value of 2x equals 3. So we can have 2x is equal to 3, or 2x is equal to negative 3. And we solve dividing by 2. We're going to have x is equal to 3 halves, or x is equal to negative 3 halves. So we can summarize as x is equal to plus or minus 3 halves. Okay, next, C. Now we have this one, absolute value of quantity 2 minus x equals 5. So we can have 2 minus x equals 5. And also 2 minus x equals negative 5. And we can just solve for x. And what I'm going to do is add x to both sides here, and subtract 5 from both sides. So we have cancellation there, 2 minus 5, negative 3 is equal to x. And then we have for this one here plus x plus 5 plus 5. So those would go away. Those would go away. 2 plus 5 is 7 is equal to x. So we can just, x is equal to -3, 7. Okay, so that would be that one. Okay, next, D. Okay, for this one, we have absolute value of quantity 2x minus 1 minus 3 equals x. What I recommend for these is isolate your absolute value bracket by adding 3 to both sides. And so what we have is absolute value of quantity 2x minus 1 is equal to x plus 3. And so now we can rewrite this. We can solve for the absolute value by writing 2x minus 1 is equal to x plus 3, and also 2x minus 1 is equal to negative x plus 3. And now we can solve for x. So we can subtract x from both sides here and add 1 to both sides here. So we have x is equal to 4. That's one of our solutions. And then for this other one, we're going to have 2x minus 1 is equal to negative x minus 3. And we can add x here and add 1 here. So we have 3x is equal to negative 2. So x is equal to negative 2/3. And so in set notation, we'll have x is equal to negative 2/3, comma 4. So that would be that one here. And now for the last type of thing we're going to look at here is absolute value inequalities. So for absolute value inequalities, what you have is a situation. You're going to either have absolute value being less than or greater than. And I have a little mnemonic device that helps us remember what's going on, and it's this. More is or, and less is nest. And so what that means is that for less than, you're going to get a single interval. And for more, you're going to get a less than interval or a greater than interval. So let's check this out with this first one. To break this up, we're going to take this x is less than 2, so we can rewrite this as x is less than 2, but also x is greater than negative 2. So there we have x nested in between negative 2 and 2. And so in interval notation, we would write that as parentheses negative 2, comma 2. And that's going to be it. That's all there is to it. Next one, we have absolute value of quantity x minus 1 is less than 2. So again, we have less than. So we take this x minus 1 is going to be less than 2, but also greater than negative 2. And then to solve for x, we can add 1 to the middle interval, and we have to add 1 to all the other intervals. So what we have is x is greater than negative 2 plus 1, which is negative 1, and less than 2 plus 1, which is 3. So our solution set in interval notation is going to be greater than negative 1, less than 3. And that's it. Okay, now for C we have absolute value of quantity 2x plus 1 is greater than 3. So in this case we have greater than, so we have 2x plus 1 is greater than 3, and remember more is or, and we're also going to have 2x plus 1 is less than negative 3. And so it's like we divided by a negative number, so that reverses the sign. That's how we came up with this. And we just go ahead and solve for x. So we have 2x is greater than 2, so x is greater than 1. And then over here we have 2x is less than negative 4, so x is less than negative 2. So what we have in interval notation for x is less than negative 2, we have negative infinity, comma, negative 2, union, 1, comma, infinity. So that's going to be that. And now for D, we have this absolute value of quantity 2x plus 1 is greater than 15. So we have 2x plus 1 is greater than 15. And we also have 2x plus 1 is less than negative 15. And we just solve for x. So we have 2x is greater than 14, so x is greater than 7. And then we have 2x is less than negative 16, so x is less than negative 8. And so we have here in interval notation negative infinity, comma, negative 8, union, we have 7, comma, infinity. So that's going to be it. So I hope this has been helpful to you. Good luck, and as always, thanks for viewing.